Welcome to another lesson in Unit 2, Manipulating Graphs. This lesson is on reflections. As you've seen this before, just some rules to remember as we're going through and transforming our functions. You're welcome to hit pause and look through that a little bit more if you need reminding. Today we're going to worry about in front of our functions or inside our function. All right, so this A or this B, and not necessarily the numbers, but the sign. All right, before you look at these graphs, let's look at this chart. Okay, when we have reflections, really that's just looking at the positive or negative signs in our function. Okay, so if we have a negative outside our function, always looking at the right side. If we have a negative outside our function, that's going to flip vertically. Okay, so what happens is we have a reflection across the x-axis. On x-axis, I'm going to run out of space here. And the rule, the x stays the same, but the y, just changes its sign. If it's positive, it becomes negative. If it's negative, it becomes positive. And we can look at that on our graph to the left. Okay, with a negative in front of our function, whatever our function is. Okay, it takes our original point and just makes the y negative. So it's a reflection across the x-axis. We're reflecting this point, and our x-axis is kind of the middle point. Excuse me. Whoops. Let's go back. Our x-axis is kind of the center, the line of symmetry. Okay, the next one, our negative is inside of our function next to the x. And what that's going to do is going to have a reflection across the y-axis. Hopefully your handwriting is better than mine. Reflection on y-axis. All right, and so what that does is it changes the sign for the x, and the y stays the same. We can see that again on the second graph. Negatives inside, okay, similar there. What it does is it changes the sign on the x. It makes it negative, or vice versa. Okay, it's a reflection across the y-axis. The y-axis is the midpoint of those 2 points. All right, let's do some example. There's a lot going on here in this slide. For now, I just want you to focus on the parent function. All right, then we have 2 reflections. Okay, we have a reflection where the negative's outside of the parent function. Then we have another reflection where the negative is inside the parent function. All right, and before we do anything else, I'm just going to go ahead and write down some points for this parent function. Well, that's a square root, okay? So I know that my negative numbers in the parent function aren't square rootable. Okay, so those aren't going to get me anything good. 0 will get me something. All right, square root of 0 is 0. Square root of 1 is 1. Square root of 2 is a decimal. Square root of 3 is a decimal. So I'm going to make my next number 4. Okay, square root of 4 is 2. You want to include another one? Might not be a bad idea. Okay, next number that works is 9. Square root is 3. All right, and then I'm just going to write my rules. For g of x, our negative is outside of the square root. And if you look back onto our previous slide, that should tell us that all that does is change the y. Okay, and then for h of x, the negative is on the inside of our function, parent function. So that's going to change the x value, and the y is going to stay the same. Again, that's from our previous slide. All right, now looking at g of x table, x's stay the same. I'm going to slip the 9 down there. But the y's change, they just do the opposite. Okay, well, those are no good still. The opposite of 0 is still 0. The opposite of 1 is -1. The opposite of 2 is -2. The opposite of 3 is -3. Okay, I'm taking my original y's from the parent function table and just changing the sign. Okay, if I go ahead and graph those, we've got 0, 0, 0, -1, or 1, -1, 4, -2, and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, -3. Okay, and that should look like the reflection of our original parent function, the square root of x. This reflection through the y-axis. For the h of x, okay, the negative is on the inside of the square root. It's inside the parent function. So that means, if you reference our last slide, okay, that the negative changes just like our rule for the x, which means the x changes, it flips signs. All right, so let's take all our x's and flip the sign. 2, 1, 0, 1, 4, 9. Okay, the y's don't change at all. 0, 1, 2, 3. Whoops, these should be negative because all the sign switches for the x. All right, and if I go and graph those, I'm going to get something that looks like just a reflection of the original parent function. Okay, you know, because of our parent function work, that the parent function comes off like this in the first quadrant. All right, but with that negative inside the square root, all it does is it flips it around. You're always welcome to plug in your own values into the function to see if your table values match, but they should. All right, 3 to the x. Let's find our parent function. Okay, blue there for the parent function. Next one, our negative outside would be green, okay, because I know that's going to be a reflection across the x-axis, flips vertically. And then in red, I'll mark the reflection inside the function across the y-axis. That's be g of x. Right, so I'll just fill out the values for my parent function. And those are the x's we commonly use. I need to plug those into 3 to the x to get my y values. If I plug in -2, I get 1/9. If I plug in -1, I get 1/3. If I plug in 0, I get 1. If I plug in 1, I get 3. If I plug in 2, 3 squared is 9. As I work my way down the page and towards the rules, okay, the rule for g of x is going to be, whoops, I was going to write the equation there. The negative's on the inside, so I am flipping the sign on the x, leaving the y the same. And for the h of x, since the negative is on the outside of the function, yeah, I am going to leave the x alone and flip the y. Yeah, the y changes. And for my table, for the g of x, that's 3 to the negative x. All I did was update my g of x function. For my table, I'm going to leave, based on my rule, I'm going to leave the y's the same and change the sign on the x's. So I'll just go ahead and leave the y's the same. Change the sign on my x's. All right, and I get those. So -2, 9, starting from the bottom. -1, 3, 0, 1, and then 1, 1/3, and 1, 1/9. Do my best to estimate. And I get this nice exponential decay function. Okay, so it took an exponential growth function and just reflected it across the y-axis. It just flipped it around. The next one, my rule says in green, leave x's alone and just change the sign on the y's. So I'm going to leave the x's alone, just plug them in as they see them in my parent function. And I need to change the sign on the y's. So negative 1/9, a negative 1/3, negative 1, negative 3, negative 9. And that looks something like this. That just takes the initial exponential growth parent function and flips it over the x-axis. So instead of looking like this, it just flips it over the x-axis to put it in the bottom of our graph. All right, this last example that you're going to have in the video is a little bit trickier. Okay, we need to find the function for the graph. So we're given the graph and we need to actually write the function rules. Well, first, what kind of shape is that? To me, it looks like a parabola. Okay, so I know my parabolas. Well, I don't want to use y. My parabolas of f of x equals x squared it has a parent function. And if I graphed it, it would appear like that. That's the parent graph, or the graph to the parent function. My graph in black does not look like that. A couple things have happened. It's flipped upside down, and then it's moved. Okay? So, first, we know we're going to have a negative outside of our function. Okay, so we're going to at least have this, because we have to flip it upside down. It wouldn't be inside, and inside would flip it across the y-axis. This got flipped across the x-axis. So our negative is outside. And also, there was a translation. Okay, we moved to the left 3 and then down 1, and it flipped. Okay? Okay, so how do we move left 3? Remember, that is like having a plus sign inside. So I'm going to quit writing the f of x over here. But we need to put a plus sign in there now. That moves us left. Then to go down 1, we need to have a subtract 1 on the outside. Okay, and h is a plus 3, and minus 1 is the k. All right, so what happens for our rule is that our x's, okay, are moving to the left 3. Okay, so we subtract 3 from all of our x's. Remember, it's the opposite of what's in the equation. And our y's need to change sign, and we need to subtract 1 from them. Okay? So we need to subtract 3 from all our x's. It moves to the left 3. And our y's need to change sign, because we're flipping upside down, and then subtract 1. So our equation we already wrote would be f of x equals a negative x plus 3 squared minus 1. Okay, so the bottom says verify your answer by graphing and comparing to what you see above. Okay, so I gave you an new xy chart there, and that's the xy chart for the parent function. Okay, and then next to it, in green, I'm going to give the xy chart for our rule. Okay, so what do we have to do to the x's? We have to subtract 3 from all of them. So minus 5, minus 4, minus 3, minus 2, minus 1. I just took the x's from our parent function in blue, subtracted 3 from them, and I got those numbers in green for x. For y's, I need to change the sign and then subtract 1. Okay, so I'll take 4 y's for my parent function. I'll take 4, change the sign, -4, subtract 1 is -5. Take 1, subtract, or take 1, change the sign, subtract 1 is -2. Take 0, change the sign, still 0, minus 1 is -1. Okay, take 1, change the sign, -1, subtract 1 is -2. Take 4, change the sign, -4, subtract 1 is -5. I will graph those points. -5, 5. Right here. Okay, which also means -1, 5. Okay. Next one is -4, -2. Oh, that's good. That's on our graph. And then -2, -2. And then -3, -1. All right. Okay, so our parabola pretty much matches that. Now, I think they just kind of screwed up a little bit on their curve. So the curve doesn't fit perfect. But yeah, it looks like we wrote the right function. We have the correct rules to match that graph. That is the end of reflections for Unit 2.